Hi, I am Varun Joshi and welcome to day 3 of our Certified Kubernetes Administrator 2025 course. Today we'll explore a few flags that can be used while creating containers, take a deep dive into Dockerfile, and create and expose to the outside world a Docker container. So I'll go to my code editor. I have the GitHub repo opened. I'll right click on day 3 and open an integrated terminal in day 3 itself. If I run Docker images, I see we have the images that we created or worked with on day 2 of this course. I'll run a container Nginx, Docker run Nginx. A lot of you might know Nginx as a web server, but it is not just a web server. It can also be used as a load balancer, as a caching server, and also as a Kubernetes ingress controller. What are Kubernetes ingress controllers? We'll discuss that in Kubernetes networking section. So once I hit enter, I see that it says unable to find image Nginx latest locally. What it is doing is Docker daemon, if it doesn't find the image locally, it tries to download it from Docker Hub. In this scenario, it has downloaded the image and our container is in running state. To verify that the container is in running state, I'll just open another terminal in a split view. I'll now run Docker PS here. Docker PS says yes, the container is running. It has given a name to this container, tender_edison, automatically. A thing to note is the container that was just created. This container was created in what is called a foreground mode. That is why the container is running like this. I wouldn't want that. I want my container to run in the background. That is, I want the container to run in a detached mode. So what I'll do is I'll hit Control C here, and once I hit Control C, I'll see that the container has exited. If I write Docker PS-A now, I see that the container has exited now. Why the container has exited? Because it has done the job for which it was started. This container was started to run a web server. By default, the Nginx image runs a web server on port 80. The web server was running, but I terminated that using Control C, which is why the container also exited. Now I want to start the Nginx container again, but this time I want to start it in detached mode. Along with starting this container in detached mode, I also want to do port publishing. We'll know what port publishing is in a little while. And also we'll assign a name to this container. Right now we see the name that was assigned was tender edison. Let's clear this. I'll now write the same command, docker run nginx, which was what we used previously, but now we want to add a few more flags here. I'll add -d so that this container runs in detached mode and not in the foreground. I'll also add a -p. -p stands for port publishing. You might also hear terms like port forwarding or port mapping. All of these means the same thing when you're discussing Docker networking. I'll write 8080:80. Now 8080 is the Docker host port and 80 is the container port. Now I want you to understand like this. If someone is coming from outside, the first thing that they will connect with is the host, and after host then there is container. So likewise, if you see this port mapping, first is your host port. Host port in my scenario is my Mac machine, and 80 is the container port. Now I hit another space, write --name, and I'll name this container my Nginx container. Now I'll press enter. Whatever we discussed just now, let's see this diagrammatically as well. What you see in black is my Docker host, which is my Mac machine. Then you see in blue, this is our container that we just ran, and this is the browser of my Mac machine. Now what I'm saying is, whenever someone hits port 8080 on my machine, they will be redirected to port 80 of the container. And why would that happen? Because we have run this command. So docker daemon will redirect anything that is coming on port 8080 to port 80. Now let's go to the browser and access the container that we just created, localhost 8080, and you see welcome to Nginx. I want you to understand one thing. The port 8080 on my Mac is now reserved for this container. If I try to create another port mapping, for example, if I try to run Nginx container 2 with 8080, this remaining the same, then this command will give me an error because port 8080 on my Mac machine is already in use. Since containers are separate entities, if I have another container of Nginx which again runs on port 80, which is what is default for Nginx runs on port 80 by default. If I create another container and then create another port mapping, this port mapping will be with port 8081. If now someone hits port 8081, they will be redirected to port 80 of my Nginx container. Let's try this. I go to the code editor again. I run the same command, but instead of naming it like this, I'll name it container 2, and here instead of port 8080, I'll mention port 8081. I'll press enter, and now if I run docker ps here, it will tell me that both your containers are running. And it also tells you that if I talk about container 1, it's 8080 is redirecting to 80. Container 2, host port 8081 is redirecting to port 80. If I go to the browser, I can type in localhost 8081, and again you see the same page. You can have multiple Nginx containers or multiple containers running on the same port, that is port 80 for Nginx, as long as the host port assigned to those containers are different. This is an important concept to grab. Now our Nginx container, both the containers are running. Now that we have understood this, let's do one thing. Let's now create a Dockerfile. For this example, the Dockerfile that we would use will be created by us step by step, and we will be using Python for this. You don't have to know Python to practice this. It's very basic code that uses Flask. Flask is a lightweight web framework for Python that is widely used for building web applications and APIs. What we have done is we have used Flask to create a very small web application that listens on port 5000 and says hello Docker. We will containerize this application using Docker. Now we know that to create a new Docker file, we'll follow the syntax D uppercase Docker file. Once we have this, the first instruction that we'll write for this Docker file is from. In the from statement, we'll write Python :3.9-lim, and we know based on our previous lectures that from sets the base image for your application. We are saying for this Python application, use Python image with tag 3.9-slim as your base image. What is this slim? Why can't we just use Python 3.9? To answer this question, let's do one thing. Let's use a docker pull Python, and then we'll add a tag here 3.9. While this downloads, let's come back here and write another statement. Our another statement would be run. Now we know a run executes commands during the build process. Example, for installing packages. Now here what we would write is pip install Flask. So we are telling this to do this. I should have added another line here. Let's add that first. That is add. Add is used to copy file from your host system to the image. So for example, I want to copy app.py. What I'll do is I'll copy app.py to app/app.py. Once I have done this, I'll write another instruction which is expose. I'll expose port 5000. This expose 5000 is just for documentation purposes. It doesn't open port 5000 in your container. So if you see my application code, my application is indeed listening on port 5000. That is how I have configured this application. But if I wouldn't configure this application to listen on port 5000, then writing 5000 here won't make any sense. This is just for documentation, so that administrators, DevOps engineers know that the application that this Dockerfile will result in listens on port 5000. Once I've added the expose instruction, I'll add CMD. Now you know CMD specifies the default command that runs when container starts. So in CMD, I will write Python, comma, double quotes, app.py. Double quotes closed. This is a very simple Docker file that will first pull this image. It will then add app.py to the image. Then it will run pip install flask command to install the Flask framework. Then it will expose. It's an instruction which signifies admins that this application listens on port 5000. Then I'll run the command python app.py. This says run this application now. So once this executes, then we can access this application. So before we move forward, I'd like to introduce one more statement that is called WORKDIR. What WORKDIR will do is, once the image is being created, it will make that folder the current working directory. Like right now, my present working directory is day 3. Whatever I do, if I do ls, it will run in this current directory. Similarly, whatever happens in this container will happen in /app directory until and unless a full path is specified, an absolute path is specified. After adding this, what I can do is I can remove these things. I don't have to add this. So now our Docker file is created. Now what I'll do is I'll clear my screen and I'll run docker build -t my Python image, and I'll use dot because my Docker file is present in the current directory. I'll hit enter. This is building the image. Let's get back to what we were discussing earlier. The image that we used here was slim. If I run docker images now, you see that Python image that is of 3.9 is of 1 GB, 1 gigabytes. The Python 3.9 slim that my Python image is using is just 162 MBs, not 162 MB all, because some is occupied by my application as well. So if I run docker pull python 3.9/slim, we can tell the exact size of the slim image. What happens is slim images do not contain the documentation and troubleshooting tooling. Troubleshooting tooling could be ping, DNS, and many more. Slim images do not contain these things, which is why they are small. And smaller images are less prone to have vulnerabilities because their attack surface is less, which is why they are less vulnerable. If I run docker images now, we can see that the original Python 3.9 slim image is just 150 megabytes. Here, 12 megabytes was consumed by our application. Now we have created a Docker file. Now we want to create a container with this Docker file. So before we do that, let's first tag this image and push this image to our Docker Hub account. So what I'll do is I'll write docker tag. I want to tag my Python image. I want to tag my Python image with, I'll add my username cloud with varjosh. I want to name this image my Python image, and I want to add a tag v1 here. Once I add this tag, I'll hit enter. If I run docker images, I'll see that there is a cloud with varjosh my Python image with a tag v1. So this will be my repository name and v1 is my tag. Now what I'll do is let me clear my screen first. To clear my screen, I'll once again run docker images. Now I'll push this image docker push. I'll enter this image name and I'll add a tag here. I'll hit enter. Now it is pushing. In the meantime, I'll go to my Docker Hub account, hub.docker.com. I'll go to repositories here. Oh, I'll have to sign in first. I'll sign in with Cloud with Varjosh account. I see that the image that I just created was pushed less than a minute ago. If I click on this image, I can see it has only one tag v1, which we just pushed a few seconds ago. Now I'll go back to my Visual Studio Code again. What we have done is we have created a Docker file first, then we have built a Docker image using that Docker file. Then we pushed that Docker image to our Docker Hub registry. Now we'll create a container which will use this image. I'll write docker run. I'll add -d so that this container runs in background. Then I'll add -p for port forwarding. Remember, our port 80 and 8080 and 8081 are already in use, so we'll assign port 8082 to this one, and then we want to forward this to port 5000 in our container. So remember, this Python application listens on port 5000, and you can see that this listens on port 5000. So what I'm saying is, whatever comes to port 8080 in this Docker host, just send it to port 5000. I'll write --name. I'll name this my Python container, and then at the very last I'll supply the image name along with the tag. So this is the name of my repository, and I'll paste it here, and then I'll also supply the version tag. Once I supply the version tag, this becomes my image name. Repository name plus tag is equal to image name. Once I've done that, I'll click on enter. If I run docker ps, I see now 3 containers are running. Our latest created container is listening on port 5000. If we hit port 8082 from our browser, we'll be taken to our container. So I'll write localhost port 8082. You see it says hello docker. Now we have containerized this application. That's fantastic, but there are a couple of things that I would like to add here. Right now, when it comes to CMD, we are using something called exec mode. Exec mode says do not open a shell, just execute this command as the very first process. Let me explain this to you a bit further. Let me go to this diagram. In exec form, commands are executed directly as a process in the container. Whenever possible, whenever you do not need a shell, always use exec form. Okay, this executes hello docker directly, equivalent to running echo in terminal. When it comes to shell form, you remember the first day we discussed this CMD echo hello docker. This initiated first a shell session, and then the echo command was run. Now, why we should ignore using shell form is because firstly is when your first process is shell, you are prone to vulnerabilities because attackers know that that container would have a shell and they can attack it more freely. Another thing is when you open a shell first, that consumes resources. Exec form consumes less resources, is secure. Shell injection vulnerabilities are not there and is faster. Since you are directly running the process that your application requires, it becomes faster. Use shell form when you need shell features like environment variable expansion, command chaining, or redirection. Let's see this in a demo as well. If I go to my Visual Studio Code, we already have a container. If I run docker ps here, I see we already have 3 containers. I'll write docker top to know what are the processes running in a container. If I write docker top my Python container, then you would see that there is only one process running, and that is python app.py. So this is something that we ran. Okay, we told, if you see the Docker file, that's our last command. Okay, this is what is running. Let's say if we weren't using the exec form, so what I'll do is I'll comment this and I'll write CMD, I'll write python app.py. Once this is done, I'll again build this image, docker build -t. I'll call this shell shell form, and then I'll write a dot at the end. Docker build. Now I'll run Docker images. It shows that my shell form image is created. I won't push this image to Docker registry because we just want to understand exec form versus shell form. I'll write docker run -d to run it in detached mode -p 8083 port. I'll forward anything that comes to port 8083 to port 5000. That is my Python containers port. Then I'll name this container. I'll call this shell form container. The image that should be used is called shell form. I'll hit enter. If I run docker, if I first clear my screen, make this screen bigger, I'll now write docker ps. It shows me that my Python container is also running and my shell form container is also running. So one is listening on 8082 and another on 8083. If I go to my browser, 8082 also works and 8083 would also work. But the problem that I want to tell you is, if I run docker top, which tells me which processes are running on a container, I'll see first my Python container. This is running only Python app.py. If I check the same for my shell form container, then you would see there are two processes running. The first process is this one, that is the shell itself, and then the command is running. Another thing that I want to highlight is, when you are using exec form, then sending the stopping signal is easy to your application because it's the first process, and the first process is what listens for the incoming commands, and it allows the application to gracefully shut down. Here, if you send a shutdown signal, then first the shell will take that signal, which would result in your application closing down abruptly. So only use shell form when it is absolutely necessary. There are few more commands I would want to share with you that you would use. One is docker logs. The docker logs can be used to check logs of a container. Here, this will show you the logs. You can use docker exec to send commands to a container. So if I write docker exec shell form container, I want to send ls, you can write it directly like this. It will ls in the container. I remember I told you we will be by default in /app directory, and that /app directory only has app.py, which is why it is listing this. If I write ls-la here, -a stands to also list hidden files, getting this output in long listing because I've also added -l flag. But if I want to log in into the container, what I can do is docker exec, I'll add -it. -it stands for open an interactive terminal. Interactive because I want to interact with this. Terminal is because I want something to put my commands into. Docker exec -it, I'll call it, I'll say that I want to log in into shell form container, and I'm writing container names here because that is convenient, but you can also provide containers IDs. You can just copy these, and then I'll write what I want to run here is I want to run bash, for example. Once I write that, you see I landed in /app directory because that will always be my current working directory based on what I have provided in the Docker file. From here I can maneuver to any directory I want, but to begin with it has landed us in /app directory. And now I'll exit from this container. So that's all for this lesson. Today we learned how to run containers with key flags, explored essential Dockerfile instructions, and went through the process of building, pushing, and running Docker images. With this knowledge, you are now equipped to containerize your applications effectively. In the next lecture, we'll start with Docker multi-stage builds. If you have any questions, feel free to ask them in the comment section. If you found my lecture useful, consider liking, sharing, and subscribing. Thank you very much.